Hello and welcome, everyone. Today we're going to be hearing from all of these experts on the stage. This is called Empowering Domestic Battery Manufacturing with Magnera's OmniSep technology. I'm Jill Pastana, the CEO and founder of Pastana Solutions. I'm a battery scientist and engineer turned consultant and the creator of Across the Nanoverse, the YouTube channel. And it's my pleasure to host this webinar today. So I'd love to ask in the chat, as you're tuning in, where are you tuning in from? Where are you located right now? I'm in Santa Barbara, California. So I'll say as a Californian, I'm super stoked for this webinar. We have some very exciting technology to share today, the OmniSep Battery Separator. But to truly appreciate this innovation and the potential of it, we're going to be setting the scene first. So we'll be discussing how it's not just this battery material that's the innovation, it's the whole business model and approach that Magnera is taking to ensure that US gigafactories have a battery separator supply and separator manufacturing capability that's made in the USA. So please engage with us throughout this conversation, ask questions. If people are asking questions, provide feedback to those questions. We really want to get a conversation joining and I see some people already commenting where they're just tuning in from in the chat. Awesome. From Germany, welcome. And so now I'd love to introduce the speakers. We have Dave, Chuja, Nader, and Aubert. And so Dave, would you like to introduce yourself to everyone first?
Well, hi, my name is Dave Rittenhouse. I've been leading the OmniSep project and team for about 3.5 years now. So we're super excited to be able to share the OmniSep platform and separator with the audience.
Amazing, Dave. Thank you. And Aubert, would you like to introduce yourself next? Can you hear me, Aubert?
Sure. Hi, I'm Aubert Demarais. I'm Director of Operations at SpectraPower. Did you not hear me?
There was a little bit of a delay, but okay. It's okay.
So again, I'm Aubert Demarais, Director of Operations at SpectraPower, which is an R&D. Okay. Anyway, Director of Operations at SpectraPower, which is an R&D and consulting company in energy storage. We do a lot of work in lithium-ion, lithium metal, other novel new technologies. And we're here to talk about the third-party validation work we've done on this new novel separator technology.
Amazing. Can't wait. And Nader, would you like to introduce yourself next?
Hi, everybody. I'm Nader Shoker. I'm the Director of Engineering at Safire, a technology company with a novel tech for battery electrolyte safety.
Awesome. And last but not least, Chuja?
Sure. Hey, everybody. My name is Chuja Du. So I'm the Director of Battery Development at Safire. So I have about 10 years experience in the battery industry from, cell design qualification, fast charging, battery manufacturing, etc. So prior to Safire, I have been working at Tesla and Oak Ridge National Lab. So good to be here with everybody and chatting about this cool technology.
Yeah, as you can see from this lineup, we got some experts in the house. Really excited for this conversation, which just brings us into our first section of this webinar where we're talking about challenges for establishing a US battery supply chain. So if we're looking at the big map, and thanks to Volta Foundation for putting this together in their battery report in 2023, as we can see here, we have so many gigafactories being built across North America. And this is actually a bit outdated. Just in the past year, so much has happened. And so I'd love to hear from Aubert's perspective, what's the current state of the battery supply chain globally?
Sure. So that's a hard nut to tackle, to crack, I should say, right now when everything has been changing so quickly, but I'll take a quick stab at that. So at a high level, basically right now, globally, China is dominant not only in EV making, cell making, most of the component making, the raw material refining. 6 of the top 10 cell makers in the world are Chinese, and then 3 are Korean. and then one is Japanese. And so it's right now a big push in the US to kind of try to catch up with the last sort of 25 years of Chinese battery growth, and trying to build the supply chain to be able to do that. And so really the struggle is that China controls most of the raw materials globally, the lithium, the cobalt, the nickel, especially the graphite. Actually, they have a majority dominant in that. Problem that you see is that basically they are routing all the materials to China and refining all those into the anode, cathode, separator, and electrolytes that are then being used to make the cells. And so for anybody to be able to compete,
froze a little bit.
locally where you want to do your cell building. And so in the US, the problem is how do you source all of those things? And sourcing the graphite is going to be a huge challenge for the US. Sourcing the cobalt and nickel are going to be a huge challenge for the US. But we're here to talk about the separator, which might be a little bit less of a challenge than something that Gladfelter and now Magnera are going to be able to help with.
Yeah, thanks for setting the scene. And it's definitely a complex situation going on. Maybe Dave, could you comment on what are the current motivations for the US then to create a supply chain?
Well, of course, there's the economic issue, as Albert referenced. China has such an enormous lead on the entire supply chain and the economic value of that. Both from the federal and state levels, there's, as we know, been tremendous financial support federally from the IRA and infrastructure bill. I'm familiar with particularly Georgia, also Michigan, the state funding that has gone to the EV and battery industries in those states. So there's the economic issue and certainly the national security, because we'll be getting into the details of the value of OmniSep, but it lends itself very much to addressing very complex battery issues that actually end up being matters of national security, very important for the military and DoD applications. So you have the economic, the national security issues are strong motivators.
Absolutely. There's so many different factors contributing to this. And it's interesting to see it, politically in the US, you have the two parties, but both are very much in favor of this, which is a really interesting bipartisan perspective, which we'll get into. And Shuja, how do you see the US supporting the creation of a battery domestic supply chain?
Sure. I can talk a little bit about how, the US is investing in, creation of a strong domestic supply chain for lithium-ion batteries. Like Dave said, first, maybe from the government, they play a definitely important role in this transformation to get US battery manufacturing supply chain. So like recent legislations like the IRA and also the infrastructure bill have set historic precedents for public investment in this manufacturing innovation. Like the IRA includes significant tax incentives and grants to support battery manufacturing, creating a stronger ecosystem for the battery production, how to from the raw material all the way down to OEMs, how to integrate them together in the United States. And the infrastructure bill also funding facilities and to allow a lot of those battery productions. And also there's the private sectors are also putting a lot of investment in this kind of a remarkable market. And we have been we've seen like billions of dollars flow into the battery technology startups and a lot of cell production facilities, EV manufacturings. So that's a lot of opportunity to grow. And also there's a lot of partnership like Dave and Aubert mentioned later, the East Asia countries, they definitely have leading kind of technologies in this, since they have been working on it over 2 decades, 3 decades. So we have been seeing a lot of a partnership, like between, like Ford, GM, and some LG, Panasonic. So that's kind of a good pathway how we can, bring in the technology, but do a US based manufacturing supply chain. And also like Tesla, all the way from raw materials down to the EV, how they vertically integrate every component of the EV battery, supply chain in the United States. That's a successful story. So when we look forward, I mean, it's definitely like Dave mentioned, like if we can have, the battery manufacturing supply chain, especially in this cool technologies, the separator, we can have it in the United States. That's going to help a lot in this ecosystem.
You touched so many great points about, how expensive it is to build this, and the federal funding that's coming in, and then that's spiking the private investment. And then you have companies that are both doing the joint development agreements and vertically integrating, right? There's all these business models and approaches trying to create this battery supply chain. And maybe the speakers here, give a thumbs up or thumbs down if you think we need more funding from the government or less, or we're good on the funding from the government. Anyone have an opinion? Thumbs up. Thumbs up. Yeah, I think all around we want more funding. Maybe we're biased because we're part of this industry, but definitely if we want that sustainable battery supply chain, we need this more investment in it. And people in the comments, like, feel free to comment if you share this perspective as well. We would love to know if you are also seeing this, because everyone has their own view along this. And does anyone else want to comment on anything around this, creating a domestic supply chain? Like maybe Nader, would you like to share, like, what are the few of the challenges in creating this supply chain?
Yeah, I don't have as much experience in battery manufacturing and supply, but I think I can sort of parallel and echo a lot of the same qualified issues or challenges that say product ideators or the product development sort of path that you might see in terms of developing a new product here in the US versus say in a place like China. When you make one of something or just a few of something, it's very, I think, easy in this country to put together the pieces and get at something that is novel. A sort of pilot scale would be feasible for sure. Companies like Magnera SpectraPower is very good, I think, at that sort of rapid prototype development. But when you start to scale it from anything above that sort of benchtop pilot level, things start to sort of fall apart. I think what I see a lot of product developers, new companies doing here in the US is utilizing US expertise to develop something. I'm thinking about a friend who is developing a pickleball technology company, actually, for anyone that knows about pickleball. It's a kind of taking over tennis courts everywhere. And in developing that product, he went to, I think, the same carbon fiber development company that Tesla and SpaceX go to develop the first iteration. And shamefully, it's too expensive for him to then continue to go that route and to connect, with the manufacturers and supplies that business was connected to, and then takes the design essentially to Shenzhen, where in Shenzhen you have this incredible experience, right, as a foreign business developer, where you're invited to the family's house of the factory owner, and they take you through this wonderful kind of vacation-like experience, right, where you get to visit the manufacturing facility, you get to see all of the connection and cohesiveness between the manufacturer and the supply, and this is why I really did think that's a thumbs up, right, for government funding, because that pipeline is attractive, and they're actively recruiting business developers and product developers from the US, and sort of just saying, look, we'll take care of everything, one-stop shop. You don't have to go to another factory. Of course you do, you shop around, but it's a wonderful kind of ecosystem that I think will take a lot of government funding and sort of vertical integration, infrastructure bill and IRA, as Zija touched on, would, I think, very much facilitate that. But that's really it, is that, either through subsidy or another vehicle, we need to drive the cost down and make this kind of, cohesive manufacturing experience possible. Perhaps there's some parallels there for battery development.
Yeah, those are some great comments. Would anyone like to add to that?
Sure. I mean, I can add a little bit. I mean, US is trying to catch up. We're not even talking about leapfrog the battery manufacturing. So, the capital investment is going to be a huge expense. When we talk about gigafactories for batteries, it's billions of dollars before even a single cell was made. So that's a lot of investment. So we definitely need to have the public and private, coordination how to make it happen in the United States. Another issue for building a U.S. supply chain might be workforce development. I mean, they have a lot of expertise in China, Korea, Japan for batteries, but in the United States, we just start to seeing some training programs for developing our own battery engineers, technicians. That's gonna take some time. So, but we definitely to see something good start to happening, and I think that's a very good thing. And if we, with the right investment and policies, we can definitely create a U.S. domestic battery supply chain in the near future, I think.
Excellent points. I really love how you summed up all those things about, yeah, it's really the huge capital investment. That's a huge issue. And while we have some funding, more is always welcome. And Albert, when it comes to supply chain resiliency and sustainability, what is needed to create this in the US?
Sure. So basically, you have to get the entire chain working together. And so you need to have access to the raw materials, you need to have access to the refined products, the components, the cell making, the pack making, the EVs. And then the other really critical piece that a lot of people are working on right now is the recycling. So you can basically then start from one direction, go all the way, and then start back in the beginning with the raw materials again. And being able to basically bring all of that to the US, build it all up at the same time, have it support each other, make sure the relationships are all good. As the other speaker said, basically be able to train the workforce in the US, learn from the Chinese and the Koreans who have been doing this a lot longer and are making batteries is really hard. It's a low margin business. It's very complex. There's 9 components, but about a billion different permutations of how you put them together and assemble them. And the tiniest little thing in one component can ruin the interaction with another and make bad cells. And bad cells are dangerous cells, and nobody wants those. So really, it's bringing everybody up to speed at the same time. Rising tide kind of pulls up all ships. The government funding has been doing a really good job about that. And especially recently, the partnerships with the Korean and Chinese cell makers. Ford just partnered with CATL for a JV. Before that, they were using SK to make their batteries. GM has been investing in a lot of new battery technologies, and they're using mostly LG Chem cells out of, Tesla.
We'll see. Okay, a little bit of issues, but I love how he was touching on, Panasonic using LG cells and all of that. Like you really need the circular economy, right, in the battery industry to create this. And it requires so many moving parts. And speaking of looking at the future now, we're kind of looking at this current state. So let's think about the potential impacts of the upcoming Trump presidency on the growth of the domestic battery supply chain over the next few years and what this holds. I think a lot of people have a lot of questions about it, a lot of uncertainty.
Sorry about that. I disconnected.
Oh, no worries, Albert. Thank you so much for sharing your insights. We're happy to have you back. And yeah, so Dave, you and I have been talking a lot about the funding through not just the Department of Energy, but the Department of Defense. And what do you see the funding coming from over the next few years with the Trump presidency?
Well, this is a really interesting question, of course. I had the opportunity to speak at the Defense Energy Power Conference on June the 5th. That is because of the capabilities and versatility of our separator, which we'll get into later. There are just a lot of natural fits for our separator in these really exotic type of batteries. And there was a panel discussion that afternoon comprised of six people from the government and the Pentagon. So what was really interesting is every one of them stated, and again, this is on June the 5th, that there would be a change of administration as a result of the election. Now, how all of those people knew that, I don't know, but their perspective was that, well, we were told as battery manufacturers and material suppliers that we needed to drastically change our budgets because those bills, the IRA and infrastructure bills, the funding from them would be impacted. Now, in contrast to that kind of very ominous message was also the statement that the industry needed to prepare to ramp up production for the military by 20 times. And they referenced conflicts that they foresaw on the future in addition to the Ukraine. And they spent a lot of time talking about how the war in Ukraine had so drastically changed the use of munitions from 2022, when the 155 shell was the primary munition, to at that time when drones were the primary delivery mechanism. So that's kind of the dichotomy that I saw, in that there's challenges and also opportunities, because to supply the military going forward, which is by itself relatively small, but the point that was made repeatedly was that new devices, new applications, new things were going to come onto the battlefield. And so we're very well positioned to fit those niches and those quantities in the large scale manufacturing, where something like a reduction of the $7,500 tax credit may or may not be existing going forward. There's a lot of exposure there. But from the standpoint of OmniSep and what a lot of the things that we're involved with, it's actually, we're very well positioned.
Yeah, thank you so much for sharing that context. And that's very interesting to get that feedback from the Department of Defense, and to kind of look forward at the challenges that they're noticing from a national security standpoint, but also with global conflict in the world. And there's such a need for that raw material supply, including the battery separator. I mean, it's really what separates the electrodes, right, and keeps us all safe when it comes to battery technology. So yeah, thank you so much, everyone, for your perspectives on this. I'd love to move on now to talk more about this battery separator technology and manufacturing, and the importance of making it scalable. And so I'm going to quickly put our other speakers in the waiting room for a moment. They're still with us, but you can't see them on the screen. And Dave, I'd love to chat more about, what is a battery separator, to kind of educate those who may not understand or not have experience with this material.
Well, thank you, Jill. And that's actually a really good point that you make, because I found a lot of battery experts kind of take the separator for granted or as a given. It's everybody knows what we've always used, and so that's what we're going to use in the future. And even going back to the inventions of Dr. Goodenough and Whittingham. Some of those same separators are being used today, and so everybody knows that's what you should use. But we've developed a unique process and architecture for a separator. The important things that the separator has to have is, I used the word dichotomy previously, and that really has to do with pore size, where you have to both separate the anode from the cathode, of course. You need to try to prevent the growth of dendrites, and those are in the magnitude of maybe 50 nanometers in diameter, so they're very small. But you also need to have a free flow of the lithium ion, and it's not only the lithium ion, but also the counter ions. So there's a lot of resistance that has to be overcome. So you need a separator that has the proper balance of pore size, tortuosity, and other things, including thermal stability, depending on the use case, what temperature you want the battery to operate at, where do you not want it to operate, for certain chemistries that if they get too hot, the cathode will exothermically decompose. Also, you need the strength for specific, particularly for a spiral wound application or use case, and of course resistance to the electrolyte, the salt, and also the separator cannot introduce or bring into the battery any contaminants that would cause any degradation of the cell chemistry.
Yeah, when you think about it, like somebody commented on LinkedIn when I was promoting this, that, it's not just saran wrap. It's not just a plastic you can put between the electrodes. It's a carefully crafted and engineered safe material. And, separating those electrolytes, preventing any kind of short circuiting, including at high temperature. And, there's so many, there's a few, I wouldn't say so many, but there's a few separator technologies that are commonly on the market today. Can you comment on what the latest is?
Sure. And this is really a kind of a easy graphic to speak to, because it separates out the various technologies that are used. Very commonly, of course, is the stretched film, also called the dry process, that's used by CellGuard. I had experience with this going back into the beginning of my career, where we used cavitating agents to pull polypropylene and pull cavities into them. That application was actually a printing paper, but it's a very similar technology. There are, because of that stretching, stresses built up that later can cause shrinkage at elevated temperatures. There's the wet process used by Entech and Saikesi and others, that utilizes ultra-high molecular weight polyethylene that's emulsified with an agent to enable the creation of cavities when that emulsifying agent is extracted with a solvent. Electrospinning has been used. DuPont used that in their Energain product. It's a process that enables the production of very fine nano diameter fibers. Very elegant process, but it's difficult to scale and usually quite expensive. Phase inversion is used to manufacture a polyamide-based or aramid-based separator. Microvast holds patents on that. And in the process of paper making, using discrete length fibers, including cellulose, that are dispersed in water and then laid onto a continuous screen, practitioners of that include Dreamweaver, Freudenberg. As I mentioned, I got into the battery lithium manganese dioxide primary battery in 1981. So I've had experience with many of these processes. In the development of OmniSep, I and the team looked at the advantages and disadvantages of all these processes, and we came up with the OmniSep process, which utilizes continuous fibers that we manufacture in our process. They're dispersed in air, so there's no introduction of water that can carry over into the cell. And it also creates uniformity and the general avoidance of creating in the manufacturing process pinholes, which are so important to avoid due to dendrite growth.
Yeah, so it's like you took all the downsides of the other separator technology on the markets, the cost, the voltage window, the porosity, the ionic conductivity, and found a way to create this non-woven separator material that has those benefits that those exhibit. And I'm really excited to get into the data that we have, with SpectraPower and talk about how Safire is using this with their electrolyte. And just also to underscore, this is made in the USA. This is something that can be supplied today, right, Dave?
Absolutely. And we list on this slide the 6 primary objectives that we set when we were designing the OmniSep process and material. Not in exact order, but certainly fast charging is really critical in certain high volume applications like EVs, where that addresses range anxiety, for example.
Or even like drone applications, right? Those are very high power applications, energy dense, right? A drone, they want it to last in the sky for 6 months straight, being recharged maybe by solar during the day. And batteries for that, they have to operate at a wide temperature range. And I'm excited to talk about too, the shrinkage. There's less shrinkage with OmniSep, which will show the data and the actual results from that. And just to kind of underscore too, what I really loved hearing from you and the team about is that Magnera doesn't just want to supply the raw materials, right? You can actually act as a partner in the battery separator solutions for companies at all stages, from R&D to pilot lines, creating prototypes, all the way through when you're ready to scale production and mass produce, right?
That's really the beauty of the OmniSep, and that was the genesis of the name, in fact, Omni, because it can be used in so many different applications. It's the everything battery separator, as they call it. So yes, we are engaged with many early stage companies where, like as with Safire as one example, and we'll talk about that later, we can determine the use case, the chemistry, and match pore size, porosity, thickness, basis weight, strength, operating temperature, the chemistry, whether it's needs to be wet out in an aqueous system, such as zinc is very popular, exciting chemistry. And we can put all these things together to make a product that's ideally designed and suited for that particular battery and use case. And the process is scalable, so it's not just a laboratory experiment. Magnera is the world's largest manufacturer of nonwovens. We're about $3.6 billion in size, so we're very, large volume, economies of scale is really in our wheelhouse. So we're able to go from that test tube to large volumes.
Awesome. I mean, it's ready to commercialize, right? And we're just looking for partners to try it, test it out with their battery chemistry, which brings us to our conversation with Safire. So just Dave, thank you so much for commenting on the OmniSep technology. And like you said, there's so many engagements with customers. And I'm going to invite back to the stage a couple more of our guests. So welcome back. We are excited to introduce Safire. And while we want to be mindful of time, we're going to do a quick intro and then go into the collaboration between Safire and Magnera.
Certainly. Thanks, Jill. I got my eye on the clock. I'll try to keep it to 3 minutes. So what Safire technology is trying to solve is, as batteries get more energetic, more energy dense, obviously they're going to also become more volatile. And the risk, once the battery is under mechanical stress of shorting and then a rapid and catastrophic degradation of the separator, is essentially the sort of main problem we're trying to address, either by way of allowing that battery to fail more gracefully, or perhaps even to protect the battery altogether. And so if you want to just click right on through to the next slide there.
Yeah. There we go.
Great. So I'll just kind of talk a little bit about what the tech is and how it works. And so essentially what it is a silicon nanoparticle that's suspended in any electrolyte. It can be tuned for any working electrolyte and any electrode. And what it essentially then does is convert or transform the electrolyte into a non-Newtonian fluid. So this is where the impetus of shear thickening comes in. So really what it is it's just effervescence, essentially, as with some marginal tax on, of course, performance. But as far as our testing has shown, depending on the loadings, it seems to be very marginal. But what it will do then is agglomerate under impact. And so that basically means that when that shear thickening occurs, as Dave kind of touched on earlier, one of the aspects you look at for battery separators is ionic tortuosity. And you can think of this as a sort of tunable tortuosity. What you then have is the ability to, say, under mechanical stress, shut down effectively the ion transport from one electrode to another. And then this could essentially lower overall heat propagation and then eventual thermal runaway. Again, that sort of fail gracefully approach. What is interesting, I think, about the collaboration between us and Gladfelter is that in order for this to be optimized, the performance of this agglomeration effect, these particles kind of coming together to jam the liquid, and so that it effectively forms what is like a solid, basically, is perhaps something that can act as a scaffolding to allow for this agglomeration to sort of brace itself against a material. And so this collaboration explores how do we tune the porosity of the separator, how do we sort of get at this kind of sweet spot of performance, without essentially affecting the electrochemical performance of the cell, but also providing that scaffolding effect so that in impacts you then have this shutdown phenomena happen.
Wow, that's really fascinating. So it's like oobleck. Like, have you ever played with that? Cornstarch and water, non-Newtonian? Oh my goodness.
I needed to keep this to 3 minutes, so I didn't jump into the cornstarch and water bit.
I love it.
So this is our team. We're building out a fledgling company of experts, and we really are at this point, in a very rapid sort of test, break things fast phase of getting our technology viable, both in impact testing and electrochemical performance testing. And Zija, of course, is on this panel as well. We have the license to 6 patents from RNL. And we have access to RNL laboratory staff as well to help in that development.
Very cool. Yeah, I'd love to hear, what's this collaboration going with Magnera and how has that been working?
So I think I'll let Zichao speak a little bit on that component and a little bit maybe more on the tech.
Sure. I think, like Nader said, we're working on some cool technology, shear thickening electrolyte, to help with the battery safety, but that we are trying to develop that technology to be separator agnostic, but at the same time we definitely need to have some expertise on the separator help us to enable that technology. Magnera definitely helped us a lot, providing different separators, and not just the separators, but also the expertise, how they're their input, how they can tune the separator properties, different tensile strength, different pore size, uniformity of the separator, how that's going to affect the integration of the technology software is developing. So I think this is definitely a very interactive development, and so the outcome going to be a win-win, so that Magnera are going to have this cool separator technology while software developing this shear thickening electrolyte, and when they combine together, you can get a much safer battery, and that's going to be a very cool technology looking into the future.
Wow, this is super interesting. Thank you for giving the overview. And it's so cool how, right, with the tunability of this separator, you can play with a lot of things, right? To tweak it, to optimize, to see how it work together. And with batteries, you always have surprises, right? Have you guys noticed any like innovations or surprises that have come out of this collaboration? Just curious.
So yeah, it's like for software, we're still like in early stage development. So there's some preparatory information I couldn't share, but there's definitely a lot of new phenomena we have been seeing in the battery testing, and but one thing I can sure to share is that the separator from Magnera has the good quality, and has enabled hundreds of cycling of the batteries when combined with our technology. So that means the high quality, high standard of the Magnera separator technology.
Well, that's great to hear, and I understand there's proprietary stuff there. So thought I'd ask, see what I can get. And
Sure.
I'd love now to thank you so much to the Safire team for joining in. We'll have you on stage for the Q&A. I'm going to now bring Albert on the stage to talk about Safire or SpectraPower. Excuse me, SpectraPower. So welcome back, Albert. Thanks for tuning in. And would you please provide an introduction to what is SpectraPower?
Absolutely. Now, hopefully, now that I'm on my phone, this works better than our spotty Comcast internet connection earlier. So again, I'm Albert Demery, Director of SpectraPower, and what we basically do is we're an outsourced R&D consulting, teardown autopsy, testing.
I think the sound got a little off, but sorry, continue.
Sure. Let me try holding the phone up and seeing if that's a little bit better. But basically what we do is we do outsourced contract prototype cell building and testing, and new material verification, third-party testing work. We tear apart commercial battery packs and cells into components and do testing. We do validation testing on large batches of commercial materials. We build A to B cells with all commercial standards versus, in the case of Gladfelter's material, now Magnera's material, basically a cell with all commercial standard materials, standard cathodes, standard anodes, standard current collectors, standard electrolytes, and then something like perhaps a commercial separator compared against theirs to see how they work. And so what we're going to see pretty shortly, I believe, is some of the testing we help do for them to basically first evaluate and then compare their materials against industry standards. And that's what we do here at SpectraPower, is we do a lot of that type of cell building and testing, and also commercial material validation and cell validation.
Amazing. So you get to see so many different types of cells and work with so many different types of materials, and often, the emerging in development materials. So really appreciate your perspectives on what it's been like to work with the OmniSep battery separators and how it measures up to what you're seeing on the market today. And so this, just to show, is a cycle chart of the OmniSep separator in a standard lithium-ion battery cell. And you can see the darker lines are the OmniSep cell with a 15 micron separator and a 22 micron. And then the lighter purples are a CellGuard separator of comparable cell design, right? Mm-hmm. So you're seeing the cycling, Albert. What are your thoughts on this comparison?
Sure. The first couple of things that I want to say about this is, so what this is basically showing for people that maybe don't understand, cell cycle results are, It's showing the number of cycles that these have gone through full charge and discharge, starting at an initial capacity. And what you'll notice is that the cells with the Omni separator are both started a little bit higher than the cell guard. And so really what you want to watch here is you want to watch the degradation rate. How much does it fall over the amount of cycle? And in order to basically have, kind of a valid commercial product, what you're really looking for is you're looking for over 80% of original retained capacity at sort of 500 to 1,000 cycles. And what you're seeing here with these two cell guards, which again are industry standard materials used by many cell companies in some of the best cells in the world, you're seeing that the OmniSep, although you do see that it starts a little bit higher, basically is just as flat from a degradation rate as the cell guard, which is huge. That is a very impressive thing for a new material from a smaller company. Although, let me rephrase that: a smaller team at a large company, but a new product introduction. But a new product introduction compared to what really are some of the industry standard materials used by everybody, and you can see that it does just as well for cycling. And the other thing to notice here is that there's a little bit of noise where you see it kind of going up and down. What that is, just to explain that away, is that's just basically cells change performance at different temperatures. And so that's just our lab's thermometer changing between day and night cycles during these cell tests. Hi, Jill. I wasn't able to hear anything you said just now. Are you guys still able to hear me or no?
I can hear you, Albert.
Oh, great. I wasn't able to hear anything Jill said recently. Looks like there's a question from the audience of what type of cathode and anode. If I remember correctly, this was a standard graphite with NMC 811 to answer the question of the audience.
Thank you. Yeah, sorry, I was on mute. So, muted myself. Thank you for answering the question. Great.
Sure.
And moving on to more data to show, we have next the shrinkage. So we talked about what happens to the separator at high temperature. Can you talk us through these results?
Absolutely. So basically, actually, one of the more impressive things about the OmniSep is that it has this very high thermal tolerance compared to standard, poly separators like the cell guards, which, at kind of a high level, what happens is as cells heat up either through usage or bad chemical reactions, or they're left out in the sun, or they start going through thermal runaway type events, they will start heating up rapidly, and somewhere between sort of 90 and 120 degrees C, you'll start seeing normal separators begin to shrink. And when separators shrink, what happens is they stop covering the anode and cathodes. And if those touch, you'll get a short circuit, and that gives you a huge, horrible thermal event blow up. That's simplifying things a little bit, but basically what you're seeing is that the Gladfelter OmniSep at these higher temperatures really doesn't shrink, and traditional separators do. And I'll try to speak to just the ones here, but we tested a very wide variety of OmniSep separators against a pretty wide variety of cell guards, different thicknesses, different types at different temperatures. And over 150, when you go to like 170 to even 200 degrees C, the cell guards will basically shrink into either almost out of existence, or they will literally turn into a puddle of liquid, and the Gladfelter materials don't. So it's a very large, significant difference in thermal resistance, which is a huge benefit for safety and handling for cells.
Wow. Yeah. Thank you so much. And I think, we have this comparison, which apologize for everyone, all the data that's being shown on the screen, but essentially, what the Magnera, they used to be called Gladfelter. Gladfelter was acquired by Magnera. So sorry if there's any confusion there, but we're seeing that in both directions, right? Both the machine direction and the trans direction, the shrinkage properties are great compared to what's on the market today with CellGuard. And Dave, do you want to speak a bit to the higher air permeability property too?
Yes, that's a really important feature because as you can see here, the air flow through rate of the OmniSep separator is very, very much higher, like almost 2 orders of magnitude higher than the CellGuard. And that eventually translates into ionic conductivity improvements. And I'm not sure if we're going to put all of the data that Albert had generated in SpectraPower, but we've finally been able to tease apart and show how this conductivity difference, this airflow difference, manifests itself by doing low temperature cycling at 0 degrees C. And at those temperatures, we can see between the 30 and 35% improvement in charge and discharge rates, et cetera. We only developed this data in the last couple of weeks, so we're not presenting it, but we'll be doing that and even lower temperature down to -20, -40. But that's really significant because even EVs in Minnesota, Canada, they're going to experience that, and those kind of temperatures, and to get such a improvement and is really almost you can consider a breakthrough. And of course, military applications, and of course, space and deep space, where you experience these low temperatures that all come back to this data of airflow rate.
Yeah, and on that note, with airflow connected to ionic conductivity, you did do a lot of rate testing at SpectraPower, and these are done at room temperature, right? And just the comparison for these. So maybe, Albert, do you want to comment on what we saw with the rate testing?
Absolutely. And again, what this testing really is showing is it's trying to compare what is the performance of the OmniSep on a A to B comparison. Everything else about the cell is exactly the same electrodes, the same design, the same sizing, and it's comparing a very similar thickness of the Magnera separator, a 15 micron versus a 16 micron dry process separator. And what you're seeing capability with a C/3 to 3C kind of rate ladder are basically identical, if not even a little bit higher in some cases even. And so that is an extremely good result from, again, kind of an early version of their new product. So to speak frankly, we were pretty impressed the first time.
Yeah.
The other thing to maybe mention is go ahead. I was just going to say, well, one of the things to mention is that the really high temperature ability and also the kind of rate ability are both features of their materials and their manufacturing process. And so these are one kind of combination they have right now. But what's really exciting to me is that they have the lever arms to basically change a lot of these properties, the pore sizes, to allow greater ionic conductivity, which everybody wants thinner separators, but thick enough to be safe, and the temperature durability. And so their ability to basically be able to customize, I'm excited about for all of this.
Yeah, customizability is really that key here, where you can optimize. And I see somebody commented that, yes, Safire did sample and is testing with Magnera for their system, but this data is not Safire's data. This data is purely just your standard lithium-ion battery cell with a standard electrolyte formulation that Magnera wants to share to show comparison with the state-of-the-art advanced battery separators on the market. And exactly what you're saying, Albert, with this tunability opens so many doors to exploration of how the full battery chemistry can be optimized. So thanks so much for highlighting that. Are there any other thoughts you'd like to share about working with the Magnera team on this technology?
just maybe a quick qualitative is that it's always great working with people that have manufacturing experience, because so many people start working kind of a lab in gram scale, little sheets or post-it note sizes of material. And as kind of a first evaluation set, getting, 100-meter rolls of material that we could slot into an automatic stacking machine really was to show how far along they are and the kind of capabilities and manufacturing expertise that comes from a company like that. And so the normal company we would start working with kind of early product stage needs a lot more hand holding to be able to take their material and be able to build it into cells. You have to give them a lot more feedback on how to aim towards manufacturability. And none of that was an issue here with the OmniSep.
That's incredible. And Dave, would you like to share thoughts on just these preliminary results and what this means as far as the next step with the OmniSep and what's coming?
Well, thank you, Jill. We have what this does is it gives us a baseline of what we're calling our standard product. Our 12, 15, and 22 are, that's the name for them temporarily. But if people want to test material, we have that available. And we're able to move from that to the customizing for their specific cell chemistry and use case. So based on our air quote standard products, baseline products, that's where we start, and then we can adjust from there.
Yeah. And what about when it comes to partnering with different companies? Like, what do you think are the best types of companies that should engage with this new separator technology?
Well, that's really a great question too, because we I think are uniquely positioned so that we can provide easily, I'm going to say relatively easily, modifications, because our process has, as Albert said, so many levers that we can turn. It's not a tinker toy or something that's only in small scale. We can readily ramp up to semi to small scale full production very quickly. I mean, in a matter of weeks to a month or so. So there's not a limitation on the size of the company that we can work with and provide a very clear line of sight to supplying their production needs. And we have very many early startups that have great ideas, and that's really something that's been very exciting about this project. By definition, it has attracted the leading edge companies in the world that we're working with and are going to be the new technologies. And
that's exciting.
We're there, yeah.
Yeah, and this is a perfect segue into our Q&A session. So I brought everyone else on the stage. So feel free, if you're tuning in live, ask in the chat if you have any questions for any of the speakers today. We do have a few questions, and what you're sharing, Dave, just now on, the separator becoming available on the large scale. So yes or no, is it ready? And do you have any more data that you can share with companies who are interested in learning more around the safety of this technology?
We've been working on destructive testing and to show improvements. We can. I don't have anything prepared at this time, but
yeah, people can connect with you offline, right, to get more information on the safety tests.
Yeah, absolutely. And just a quick note about safety. Safety is a great word, but it's not fully defined. So it's some person, what is safe, so certainly much higher temperature stability, well over 200 degrees C. I mean, we can readily provide a separator that'll maintain its integrity up to the mid 200s. So that contributes to safety, of course.
Absolutely. And is the separator available at large scale then?
Yeah, absolutely. Large also needs to be, you know, defined. I mean,
yeah.
But I'm just trying to think of a metric. Small truckloads. Yeah, I mean,
yeah.
As many batteries as I could think of, we could supply.
I mean, in conversations with you too, it's not just about, you know, supplying the separator itself. It's about, does a gigafactory want to license the manufacturing perhaps, or do some kind of joint agreement to manufacture it?
Well, yeah, just to give a kind of a broader context to the question that's being asked, we have a production process or platform that, because of that platform, combination of that platform, and we don't have a rigid paradigm already in place, that gives us the ability and the scalability to grow or site production capacity at a distant location. We can have a conversation about any kind of business venture, JV, licensing. I don't have the purview to make that deal, if you will, but we can have that conversation. Our process is very robust, and by that I mean when we go to make material, as we did last month, we're going to go make more of a different design. By 9 o'clock in the morning, we are on target. Everything's at its set point, and from there, we run our experiments or make more product or whatever. So it doesn't require, if you will, a miracle for the process to work, and just skilled production people can run the process. So therefore, we have a lot of flexibility around how to provide very large scales to any quantity or size of gigafactory.
Yeah, that's so important for creating this North American battery supply chain, right? And having that available.
Yeah, where that has gotten a whole lot of interest has been from, for example, state economic development agencies. They're all very excited about, oh, we can capture that part of the supply chain that's going into these lithium-ion batteries are being made in the state, but the separator is being made outside of the state. So how can we capture that part of the value chain? And we offer an answer to that. So a lot of constituencies can benefit from our process.
Absolutely. And we do have a question for Safire. Was asked, what is your electrolyte carbonate based, if they may ask?
So you want to take this, Sijia?
Sure. So our technology is really not just separator agnostic, it's also electrolyte agnostic. So it's a drop-in additive into any conventional battery electrolyte that can shear thickens only under impact, under high shears. So our technology, we believe, can work with any electrolyte chemistries. And if you have any innovative ideas, we can definitely test its compatibility with that electrolyte. Later, you can add anything if you have.
Yeah, we get this question a lot because we essentially affect the electrolyte or are suspended in the electrolyte, but very interestingly, we don't introduce it through the electrolyte. If you imagine, since we make the electrolyte into a shear thickening non-Newtonian fluid, imagine if we were to inject it, it would simply get clogged in the injection mechanism, right? So this is why we have collaborations with companies like Glatfelter and Dave, because we have to cleverly pre-position these nanoparticles upon and within the separator, really because we're after the hottest buzzword in the industry, right? Drop in. We want to basically not affect the manufacturing process. And so if we can just simply introduce a separator and have our technology be positioned on it, when the battery is assembled and the electrolyte is backfilled, if we design this properly, the nanoparticles will evenly disperse and become a colloidal solution with the electrolyte, any electrolyte. Yeah, so good question though. I think it needs to be clarified.
Yeah, thank you so much. That's so interesting. And we did get a question early on too about just the raw materials supply chain. And does anyone want to talk a bit about how difficult is it these days to get these raw materials in a way that is cost effective for these budding gigafactories in the US?
I would take a stab at answering that. The answer is you can't. So if you have not already secured your raw material supply chain probably a few years ago, what you have left over are basically the highest price, top of the market, marginal cost for everything, and you can't afford to turn your factory on. So that's a problem right now where a lot of smaller companies and emerging companies basically just can't afford to do the manufacturing because their material prices and therefore their sell prices are so much higher than the large Chinese and Korean companies. That's really the crux of why people have to go to them for help. Is not only does it take a long time to set up, not only do you have horrendous yields your first couple of years building stuff, but their long-term supply contracts are an order of magnitude cheaper than yours will ever be. And if you're fighting them on that basis, you lose. So the answer is it's a little pessimistic, but it's a reason to partner and it's a reason to build out the supply chain in the US.
Yeah, and I get a lot of questions through my TikTok channel asking about battery recycling. And do you see that as playing a role in recovering any of this raw material to help with the supply chain?
The answer to that is absolutely, if they can recycle cost effectively, and that is a big problem to be overcome. And I could talk about that for hours, but recycling has to be part of the equation, or what you're really doing is you're just shifting the pollution from running a combustion engine to the pollution of the mining, refining, and cell building. If you're not recovering those materials and closing the loop on the mining, refining, recycling, cell building piece of it, it's actually not better for the environment than a combustion engine.
Yeah, exactly. It takes that full circularity picture and the collaboration between different parties along the battery value chain to really make sure that you're, lowering all your costs that you possibly can, right? Like you said, there's like very narrow margins in this kind of manufacturing industry. And also having the readily available materials domestically as much as you can help create that circular economy where you have more control over the process and your scope 1, 2, and 3 emissions that you're going to probably need to be reporting to stay within the current policies, right? Yeah, and we got so many good questions so far. If you have any more, please feel free to ask them. We got a lot of thank yous in the comments to the speakers today. So thank you all. Let me pass that along to you, that good energy. Are there any topics you guys want to share about that you don't feel like we spent enough time talking about today while we have a couple more minutes?
Just the last note that I would provide is we and my team are very open and anxious to work with.
I was going to say.
Oh.
Go ahead.
Oh, well, we're just very anxious and eager to work with the people out there who are developing new things or want to try our material in their application to see for themselves the benefits that we talked about here and how those can be imparted into their battery systems.
Absolutely. Absolutely. It's so exciting to be at this stage where it's like ready for commercialization, ready to bring on the partners to really innovate and make those battery breakthroughs. And Aubert, you wanted to share something as well? Oh, there's a lag, I guess. Albert, do you want to share something?
So this is a very quick. Sure. Yeah. So what I was going to say before I interrupted Dave with my lag was one of the things that people are really focused on right now in the U.S. with the IRA is basically you get this IRA $7,500 tax credit when you're buying an EV as a consumer, but you only get it if you're using enough of a percentage of the car and basically made in the U.S. And one of the big problems with that is 40% car cost is the battery for EV. And so almost all of that comes from outside the US. So every year that percentage notches up higher and higher. And eventually by 2030, most of the car has to be, and therefore most of the battery has to be from US made material. And so the thing I just want to highlight is it will be almost impossible to bring the graphite, nickel and cobalt, and lithium fully online in that time frame. It is not unreasonable to think that Magnera could be fully producing their separator fully in the US, and it would fully qualify for that in that time frame. And so, anyone here that's trying to qualify for the IRA, you really need to be looking at where you can source your materials in the US in order to get that IRA $7,500 tax credit off of your EVs.
That's a really great point. And, while with the Trump presidency, it calls into question if the EV tax credit will continue. So far as we know, it's still there and those requirements will still be in place. Does anyone have any thoughts on, with the Trump presidency, whether he will take away that EV tax credit from what you're hearing?
I don't know.
Yeah. Remains to be seen. But for now, now, when I bought my Tesla a year ago, I got to reap the rewards of that tax credit, and that really helped me afford to purchase that vehicle. So I definitely see it as such a benefit to have those kinds of incentives. And then they also go to creating that sustainable supply chain domestically. So it's really a win-win to have those kinds of consumer benefits. And on that note, I want to, I guess, Dave, do you want any final words before we close out today?
Just to kind of magnify Albert's comment, because I didn't make this clear earlier, but Glatfelter, who merged with a division of Barry to form Magnera on actually November the 1st, Glatfelter was a United States company founded in 1864 in Springbrook Grove, Pennsylvania. Headquarters were in Charlotte. Magnera is a U.S. company. We have a total of about 9,000 employees, a turnover of about $3.6 billion. Everything about the OmniSep product platform, raw materials is all U.S. based, designed in the U.S., made in the U.S., the equipment's U.S. So we're 100% compliant in that regard. And just wanted to give a little legacy about this company, Magnera. As you mentioned, where the team is small, the company is large, has great resources, and we're excited about this webinar and the chance to meet the people who have been joining in.
Yeah, well, thank you so much for openly sharing your technology and these results and, this progress, and that we're contributing to creating this future of the battery industry in North America. And I want to thank you so much to all the speakers too. And thank you so much for taking the time to chime in, share your insights and perspectives and technology yourself. I hope that those of you who viewed this, reach out to these people if you want to learn more from them. And if you find their technology fascinating, I'm sure they'd be happy to chat and meet you. And I guess with that, contact Dave. His email's right there on the screen, dave.rittenhouse@glatfelter.com. I'm sure the email will transition, but it should still work. And
for a few months, yeah.
Yeah, with that, I'll end the stream today, and feel free also, for those of you viewing after the fact, you can comment as well. Check out the description below for more resources, and we look forward to seeing you in our next webinar next time. So thank you all. Bye.
Thanks for having us.
Okay.
Bye-bye.
Thanks, everybody.
Bye now.
Bye-bye.